Hello and welcome to a new video. Today we are working with finding limits graphically. So we are given this piecewise function, we are given its graph, and we are asked to find the following limits. So let's start by finding the limit of this function as x tends to minus 2 minus. So x tends to minus 2 minus means I'm looking at the limit at the value negative 2, and I'm approaching this value from the left side. So my value is negative 2, and this indicates I'm approaching it from the left side. So x is less than minus 2. So on my graph, I will first locate the value minus 2 for x. And since I'm approaching it from the left side, I will actually hide the right part of the graph. So anything that comes after minus 2, I'm not interested in. So I'm going to do this. So now I'm just looking at this part of the graph. This is minus 2. I'm approaching minus 2, so I'm looking at values very close to minus 2. I'm taking these values and I'm trying to see the y value of these points that I chose. So if I go back to my graph, I notice that I'm approaching this value, and if I read the y value here, I know that the y value will be 2. So since the y value is 2, I know that the limit is actually 2. Let's work on finding the limit as x tends to minus 2 plus. So again, I'm working with negative 2. So I should be looking at the value x equals negative 2, but I'm approaching it from the right side. So x should be greater than negative 2. So again, this is my negative 2 here. I should choose values bigger than negative 2. So for this part of the graph, I'm really not interested in this because I'm approaching from the right side. So taking values that are close to negative 2 but bigger than it, like these points, I try to locate my graph. So I have to go down to locate my graph. And as I come closer and closer, I notice that the value is close to this. So y is negative 5. So notice when I'm taking the right limit and the left limit here at negative 2, they are different. These are not equal. So we say the limit does not exist. For a limit to exist at a certain value, the right-hand limit and the left-hand limit should be equal. Let's move on to part C. I'm finding the limit as x approaches 2 minus. So I know that the value I'm interested in is 2. So x is actually 2, or I'm approaching 2, but I'm approaching it from the left side. So we're looking at things less than 2. So this is from the left side. So first I will locate 2 on my graph, x equals 2. This is x equals 2. I will take points that are less than 2. So notice the graph after 2, if I'm taking values bigger than 2, it's this graph. I'm not interested in this. I'm taking values less than 2. Less than 2 is this graph. So when I'm locating the values of y for these points, I'm actually going back to this graph. The value is almost 1. Remember, if it's not exactly 1, it doesn't matter. We can just be approaching the value 1, and we are allowed to say that the limit is 1. So even if I'm not taking the exact value 1, notice we are not doing that because of this empty circle. But saying a limit is 1 also means that f of x might be close to 1. It doesn't have to be 1 itself. Moving on to part D, finding the limit as x approaches 2 plus. So I'm interested in the value 2, but I'm approaching from the right side because of the plus. So x is actually taking values bigger than 2. So again, I'm going to locate 2. I'm not interested in any graphs before 2, so I'm going to go both of these graphs. I'm interested in whatever is after 2. So I'm moving slightly after 2. If I locate the point, it's actually very close to the x-axis. So the value of y, if I'm looking at the value of y, it's actually 0. And again, even if it's not exactly 0, it's close to 0, that's enough for me, because we're talking about limits here. On, we want to find the limit of f of x as x approaches 3 minus. So the value I'm interested in is 3, and I'm approaching it from the left side, because we are talking about 3 minus. So as a first step, I will locate 3. Any graph after 3 I should ignore, because we're saying x is approaching 3 minus, so we're talking about the left side of 3. So any graph to the right side of 3 I will just ignore. So I'm not even looking at this graph, I'm just looking at whatever is before 3. So you're taking points that are very close to 3, but from the left side. If I try to locate the value of y, some of you might say this is close to 3, but notice if you move closer, the value is closer to 4. If you move even closer, the value is like increasing and increasing. Even though they just drew this part of the graph, you should keep in mind that the graph is actually going upwards. So even if they stop here, the graph is just continuing in the same manner, meaning the closer I come to 3 as a value of x, the higher the graph will be, and the bigger the values of y would be. So in that case, since the values of y are increasing indefinitely, this means my limit is positive infinity. So anytime you have a graph that's going upwards like this, and I'm interested in the limit at this value here, whatever that is, since the graph is continuing upwards and so on, then the limit will be positive infinity. Let's look at the limit when x approaches 3 from the right side. So x approaching 3 plus. So again, I'm interested in the value 3, but I'm looking at the right side of 3. So if you take some points and move closer and closer, you're not stopping at a certain value. What you should be noticing is the values are decreasing. Minus 2.5, minus 3.5, minus 5, and so on. So the graph is continuing downwards. So this means my limit is negative infinity. For part G, I'm looking for the limit of the function as x approaches negative infinity. So on my graph, I'm looking at this side of the x. I don't see negative infinity on the graph, but I can tell the behavior by just taking some points. So going as far as we can on the graph, you should notice that for this value, the y is 2. For this point, the y is 2. For this point, the y is 2. Since the line is just a horizontal line, so the y value is going to be fixed. So even if we extend the graph, it will always be 2, meaning the limit is 2. For part H, same approach, limit as x tends to positive infinity. So we'll look on this part of the x-axis and take several points. And we should try to read their y value. If I go back to the y-axis and I read the y value of these points, you'll notice they're all like coming really close to this value, which is -1. Even if they're not taking the value -1, I'm still allowed to say that the limit is -1, meaning when x approaches positive infinity, the function f of x is going to approach the value -1, even if it doesn't take it exactly. Thank you for staying with me till the end of the video. Don't forget to like, subscribe, and share.